All right, welcome back. I think we're going to continue where I left off, working on this new UI feature. This is part two. Um, I don't remember what the video is called. It's like Query Builder UI feature, right? So, um, gonna be working on that. There's still probably some things that I'm gonna talk about before I actually get to um, actually writing any code or anything. Um, but we'll just talk. We'll just talk where I left off, right? So we're in this new module for the actual UI element for this widget query request. And so let's see. I left off on this new type being a sequence of sentence trees, right? So we saw that it was very similar to this request here, where this request is a list, but instead now we have a sequence. The reason that this is a sequence is just that sequences are kind of like, I think they're kind of like doubly linked lists, kind of. You kind of just can go back and forth through them. You can add elements to either side of them in constant time. It made a little bit more sense for me to implement it as a sequence rather than as a list. Although I don't really think it matters all that much. It probably could be a list, and that would be fine to do it that way. But I just went ahead and made it a sequence. There are already a handful of things in the UI that are implemented as sequences, but those actually make sense for those to be sequences, and this doesn't necessarily have to be. But that's really not the point at all. So this is essentially the same thing as a request. It's just a sequence, some kind of, maybe if you're used to Python, it's some iterable of sentence trees, right? And then we have this other new type here, this widget sentence branch, and that is basically the UI analog to this constructor right here, right? And so it's this constructor specifically. So this has a sentence tree type in it, so it could potentially have either of these types. But in practice, and the reason that I made it a new type is because it'll only ever have data of this constructor in it. And so I think that that's kind of another good reason to use new types, is that if you have some type like this, but you only want to use like maybe one constructor of it, rather than just using the whole type where you have kind of an ambiguous reference to either of these, you can kind of make it a little bit more explicit that you only want to use either a certain constructor or a certain set of constructors just by wrapping it in a new type, and then making that new type abstract, right? So from this module, I only export the type constructor. I don't export its actual data constructor because I want it to be kind of an abstract type. You shouldn't be able to make this yourself. You should only be able to construct it using the function that I give you, which is this one right here. This is the only function that will construct this type. So this is the only way. So this essentially serves as your entry point to that type. And we can see here that when this type is constructed, it's using the data constructor, only the data constructor that I want to use, which is this sentence branch constructor. So if you're familiar with Haskell, right, you know the difference between type and data constructors. If you're not, then I don't know. Maybe it's not that weird of a concept. I don't know. Maybe it took me a little bit too long to understand. but um, but that's it anyways. We just have that new type wrapper for a sentence branch that holds a sentence tree of only one constructor, only one type of constructor. Right. So here we have the entry point for that. Let me think here. And so that what a sentence branch is, and let me run this program again. What I have in mind for that is that each one of these widget sentence branches is going to be one of those query boxes that shows up, right? So a sentence branch is going to be one node, and then this widget query request, is going to be that entire element. So it'll be that whole sequence of nodes. So this is just me, this is just me defining the types that I want to use for this UI, right? So these are going to be these are basically just type declarations for actual UI elements. So I would like to be able to use these kind of interchangeably when I talk about a UI element. I would both mean both the actual element and then also the data type that is inside of it, right? And we'll kind of get to that more when we actually start making the element. This is really more of kind of the back-end logic for how the element is going to work. The way that the actual UI element is going to be implemented is fairly different, and it's a lot of library code. It's not really the same as just kind of like strictly Haskell code, right? It's all monomer library code, so that might be a learning experience to go through some of that. But in this module we have, let me make sure this is actually running, right? Okay, so in this module we have some of these functions, and like we have this delete function, we have a move function, we have an append function that will just add one of those nodes to the end of our request. And these are all just functions that I made just to satisfy some of these bullet points, right? And so these are the actual implementation. So we can see that the actual logic implementation for these widgets is really simple, right? For delete, all we're doing is just, we need an index for that, which will be the easy part. And then we just provide an index to our request, and then we can just delete it from the request, just like that. So very simple. Appending is easy, and this is part of why I chose a sequence, is because we want to add it to the end, right? We don't really want to have it as a stack. Otherwise, we could push stuff to the front of the stack, but then when we run the request, we'd have to reverse the stack. So that seems kind of unnecessary to me. So we'll just use it as a sequence, and then we can just push the sentence branch to the end of the sequence. And so this little operator is a sequence constructor. So we have a sequence on the left side, and that's just saying that we're going to push one element to the right side, to the right end of that sequence. And I kind of conceptualize the right side as the bottom of the sequence, right? And then the left side is the top. And then, like I said before, here's our widget sentence branch constructor function. And that takes a set operation, right? So we have this list of sentence trees in a request, and as far as implementation for this function goes, what I have in mind for it is that you basically just take the queries entered from here, right? And we talked about in the last video that each query we run in here, no matter how simple, is always one of these request types, right? So you run this cute one, and then that gives you this request, which is just, as we said, a new type wrapper for a list of sentence trees. And then if we go back to the AST, we can see here that a list of sentence trees is actually half of a sentence of a constructed sentence branch. The only other half that we're missing is the set operator. But since we're operating in the UI, we always have a set operator that's available to us, right? So that's kind of, and it's weird to mention state in a Haskell program, but that's part of the global state of the tagger function, is you always have a unambiguous set operation available to you if you need one, right? And so that's what we're doing. So this setup here is going to just be this global state here, this global setup. And so we'll take this Qt request, we'll take this global setup, and we'll just plug them into this function, and we'll construct a node out of that. And then this node is going to just be pushed here, right? So conceptually very simple, right, as far as how we're going to go from a front-end interaction to some back-end creation of our new type. Now what we have to do is basically take our back end and then create a front end construction for it, right? And so that is going to be where the bulk of the work is. So, and it's not really going to be hard work. I don't anticipate it being super difficult. We are going to have to reorganize some things and move things around, which in Monomer is not always really super pleasant to do. It's kind of just a lot of trial and error, honestly. So, and then we'll find out as we make this if we need to add some more logic, which we probably will. So, also, by the way, I'll mention these functions down here are querying functions. So I mentioned before, when you query for Qt, what I would like it to show is the number of files that are affected by that query. That's all that these functions do, is they actually run a query. Given a connection to a database, they'll run that query, and then they'll actually just return a hash set of all the files. And then on the front end, what we'll do is we'll just get the size of that hash set, right? So maybe it's better performance-wise if we know that we only ever want the size of that hash set to just write a new query to just get the count. But I think really rendering the UI is kind of the bottleneck for most of the things with this program, so I'm not really super concerned with getting the size of a hash set. I don't really think that that's a big problem. Not that I've bothered profiling this program or anything, but just from what I've found with some of the performance improvements I've made to it, is that the UI, and I suppose this probably makes sense to most people, that the UI is like 99% of the time the reason why things are running slowly. So I'm not concerned at all with this returning a hash set of files if all we want is the size of that hash set. Yeah, that doesn't bother me. So we're gonna do that. So let's see. Let me go ahead and commit these changes here, and then we can start working on some other stuff. So here we'll see also a little bit of Fossil workflow. I've started using Fossil, which I enjoy quite a bit. I do like Fossil a lot. It's pretty fun to use. So let's see. We made some functions. Maybe I can't talk while I'm writing the commit. Let me just write this out, and then maybe I'll put some music over this video, because I won't be able to talk over the whole thing. If I'm writing code, I'm probably not going to be talking during it. So I'll just add some music to it or something, right? Is it affected with an A or with an E? I can never remember, right? There we go. We can just commit that. VS Code doesn't like Fossil very much, so it doesn't really do all that well. Okay, so now this is really kind of most of the actual kind of logic in the program that I want. So now what we have to do, and this is where things get a little more complicated. Now we have to actually start making the UI components. So I might talk a little bit about how Monomer works for that. I'm not an expert by any means in how Monomer works, but I'll show you kind of my implementation of some things. So Monomer is the UI library that I use for this. It's a Haskell UI library. It's really quite easy to use, which is nice for someone like me who I'm not really very good with UI stuff at all. But I can kind of get the gist of it. But pretty much the way that Monomer works is it works with models and event handlers and events. And so we have our model in here. So all of the information that is held in memory when Monomer is running is created by these models. So like this is my global state right here, is this tagger model. This tagger model holds other models in it. It has a descriptor tree model. It has our focused file, our file selection, and some info models, as well as just some other things, right? And so maybe this is already quite evident what all these things are, right? But the focused file model is things like this. This file is inside the focused file model, which is inside the tagger model. So it's all part of global state. It's all accessible through this one model. but they're all kind of encapsulated in their own models, just really to help keep things more organized more than anything. It's really not super important that they all be in their own models. They can, all of these fields can just be in the global model, and it's not that big of a deal. But what I think I'm going to have to do for this new UI thing is actually create a new model, and it'll be a pretty small one. But I can't think of really an easy way to do it without making a new model. So we'll just go ahead and do that. So let me think about what kind of information this model should hold, right? So the model that I want to make is basically going to just be a wrapper for this data type, right? So it's going to have a sequence. It's going to have a sequence of these inside of it, and then we don't necessarily need models for these. We can just make widgets out of these, I believe. So let me think about this. I think actually we don't need to make a whole model. What we can do is just add a new field to one of our existing models. So to our file selection model here, this handles this query bar. It handles this stuff. It handles these things. So all this information is in the file selection model. So that's where we'll put the information for this new UI element. So I'm going to put it underneath our query text fields here. So we'll just add a new section here. So file selection, and these have kind of a specific naming convention. If you've ever used lenses before, you'll know what these are. Otherwise, don't worry about it. Let's see, file selection. I'll just call it what it is, query widget request, right? I actually have to change this name, so I can't quite do that. I'm going to change that field name just so it's consistent with what the actual name of the type is. Then in here, I'm going to do file selection. I would like to call it query widget request, but that would shadow that same name. And actually, I think that's fine. I might get rid of this field entirely because this is already an abstract type. So, well, you do need that to get the sequence out of it. So maybe not. Maybe not. We'll keep that. We'll just say when in doubt, just use a lot of words, right? Query file selection query widget request. Text. Now we have to import our module. Make sure I spelled that right. We'll just have to type it in manually. Import interface dot I put it in the handler. I might actually move that module. It doesn't really make sense for it to be in the handler, given that it's a type, right? Widget query request, query widget request, right? So there we go. Okay. And then since we don't have that type constructor exposed to us, I'm just going to go ahead and make a simple function just to create an empty one. I just call it empty. Like that. That simple, right? then we have to, here's kind of a initializer for our model that is created when you first start the program. So I have to make sure that all of our data fields are initialized, right? Empty widget query request, and that'll just create an empty one for us when the program starts, which is fine. Okay, so that's it as far as the model goes, right? Super simple. We just put the data in the model and it's there for us. Now what we can do next are create events. Yeah, we'll go and make some events for this, right? Expand this a little bit. So here are all of the events. Anytime anything happens at all in the program, it's because one of these events triggered it. And so these, as you can see, they're just I don't know, some types, I guess. I'm not an expert. But each of these labels just corresponds to a new event. So we can see there's quite a lot of file selection events, things like that. Some of these might correspond to like I/O events, like a database event. You know, sometimes they might just be a simple UI event. Maybe they change some piece of information in the model somewhere. The important thing is that we don't have to specify what they're supposed to do here, right? We just give them a name here, and then we give their implementation somewhere else. So we can just start coming up with some names. So let me think of some things, right? So let's see. We said, I'm going to reload this window because it's being real slow. But we want our events to basically be these bullet points, right? Because these are the things that you want to be able to do in the UI. So we need to have events that do these things. So like I said before, I already have these functions that do those things. So essentially all we're doing is just making events that trigger these functions. So we need to make events that both call the function and provide enough information for this function to be run. So we can just make events now, and then we might have to change them later, just depending on if I'm thinking with a clear head or not on actual implementation, you know, when we get to it. But we'll start with something simple here. So we'll start with the append widget query node, right? So here's our actual query event, really simple. I don't remember who said that naming things is the hardest problem in programming. I'm not very good at naming things, but I do my hardest, right? Try my hardest. I wonder if I should just call it append widget query node. Certainly tells you exactly what it's doing, right? Why not? I'm not one of those people that gets really bent out of shape about having to write long names. It's kind of ridiculous to me. I don't care if the function name is super long, right? It doesn't really bother me all that much. So let's see, what do we need for this? So when we append a widget query node, what we're doing is we are taking oh, hold on, I have to rerun that because it closed my window, didn't it? When we append a widget query node, we're taking the stuff that's inside this box, we're parsing it, we're going to parse it, and then we're going to take this global state, we're going to put them together and then make a UI element here. So, oops, I just got a notification. I'll check that in a minute or two. So as far as this function goes, all of this information is actually available to us in the program state, so we do not need to have any additional information for this event. This can just be an event that triggers something, right? So that's super simple. So I think what I might do is just go ahead and write the handler for this, just so you know we have a nice kind of end-to-end view on how maybe a model is added, how we make a new event, and then how we specify the implementation of that event, right? So let's see. We want to go to handler, wherever that is. Kind of forget. Handler. Okay, so whereas before these are just the declarations of the events, these are the definitions of the events. These tell Tagger what to actually do when an event is run. So this is throwing me an error because these are all case matches. So I'm missing a case event now for this new one we added. So that's why that's highlighted yellow. But every single one of these is implementation details for every event that's in the program. So this file is quite long, quite long, because there's a lot of events and stuff to do. Excuse me. But we can go ahead and just start implementing this. So this goes in down here. Append widget query node, right? And so this is something that's specific to Monomer. So the way that this handler works, it's a little weird. It's kind of unintuitive. Some things about it are not really very easy to work with, in my opinion, but it gets the job done. So you have these different types of, first of all, you specify the events that operate on your own model, but then Monomer has these kind of event types that are bundled with the library, like these tasks, these models, and then these events, and there's some extra ones too. As I write those, I'll talk about them. I might not even need to talk about any of them, right? But for this one, so what do we want to do for this, right? This happens basically when we run a query. So we want to take this query and we want to parse it first of all. So let me think here. We're probably going to want to have a let clause because we're going to have several pieces of information that we want to define, and it might just help us to keep things kind of neat if we have a let clause. So I'll tell you actually what I'll do for this, because these all have to take place in some list. We'll put our let clause on the outside, and then if we need something extra, we can add extra events in that list there, right? We might not even need to do that, so if that doesn't make sense to you why we're doing that, don't worry about it, because, So we've got our query, so we want to get our, first of all, we want to get our query text, right? This is going to read our query here. So we want to get our text. So for that, we're going to use our lenses, right? So we have our Tagger model available to us right here, and then we want to access the query text that's available in the file selection model right there. And for that, we're going to use lenses, which are a different Haskell library, which are useful to know. They come up a lot, probably. If you've looked at Haskell code, odds are good, I think, that you've seen lenses before. They kind of tend to show up in a lot of places. I'm not an expert with them either. I just use them as getters and setters. But we want to get our model, and then we want to kind of introspect into its fields, right? So we want to go to the file selection model. And then from the file selection model, we want to get the query text, like that. So that'll get the text that's in the query, right? That's telling us that's a text type. That's our query text, which is good. From our query text, we don't want just plain text. We want to actually parse it. So I'm going to have to import our libraries parser here from text, because we want to, we need actually to be able to invoke this function, right? Because like I said before, to be able to append a node, we need to have a sentence branch. And then to have a sentence branch, we need to have a request, right? Well, we don't have any way right now to generate a request, so what we need to do is just invoke the parser on that request, right, and actually parse a request. So that's what we're going to do here. is just parse a request here with a request parser, like so, right? So we need to import our library's internal parser, which I'm glad that I exposed that. I figured that I would need that down the line, and today I do need that, so I'm glad that I did that. We're in the wrong module. Hold on. Import text.taggerql.parser.internal, right? So now we have access to our parsers. So we want to parse this text here. So what we're gonna do, I'm gonna just call this since we have a let clause, like, we might as well just use it to define all of our values and just give them names and make them easier to work with. So we will call this raw query text, like that, right? And then also what we want to do is just strip spaces off of it. So we'll call text.strip on it and just get the spaces off of it, so we don't have to worry about that. Okay, now we are going to have our parsed request, and we're just going to parse this, right? So I think I exposed that parsec function in the internal parser, so I should be able to just call it here. So let's see, we need our parser, so we need a request parser. We need a stream name, so we're going to just call this Tagger query node. It doesn't really matter, honestly, what it is. Let's see, this is telling us that we still need a text, which is going to be what the raw query text is. So there we go. Now, this runs the parser on the text, and it's going to either give us a parse error or it's going to give us our request, which is perfect, right? So then what we need to do also is have a way of handling errors, right? So, let me think. This is going to get kind of actually a little bit annoying to do now that I think about it. Not impossible, but maybe a little bit bothersome. We need something like this, right? So we need an either and then just return nothing, or do some action with our parse request. Right, something like that. The thing is this function gets invoked on the parse error if there is one. What I would like to be able to do is display that parse error to the user, right? So I think I might have to actually kind of write this. It's going to require a little bit of thought to how I want to do this. I'm thinking, something cool would be to write it with a kind of a do statement on the either. Just got to think about how exactly I want to do that. So this is where the music is going to come in, right? So I can be quiet for a couple minutes while I think about this. Let me try this. I'm going to try something that's like obviously kind of harebrained, and then we'll just see how it goes. So, Now see, list is a monad. I don't really use list as a monad very often, so I'm really not super comfortable with how it works. What I want to be able to do is use an either in the monad. So what I'm going to do, no, so what I was thinking of doing was not what I want to do. We'll hold on to this. let's go ahead and actually just write some of these as standalone functions. That might help me to kind of conceptualize what I want to do a little bit better. So here what I want to do, okay, I'm going to do something kind of stupid. I'm going to actually write this as a function instead of just a value, right? Values are functions and functions are values, but I'm going to write this as a function. So what I want this function to do is to take parameters of a of the result of parsing something, and I want it to take a set op, and then I want it to return a list of app event responses, and then this is going to be the body of our handler here. So, and that's going to be a function that helps us generate that. So let me think, what do I want to call this? I want to call this we will just call this a parse widget sentence branch. It's going to take some text, it's going to take a set op, and it's going to return something. I'm going to give that a type annotation just for now, just so maybe it's a little bit more clear, right? It's going to take some text, it's going to take a set op, and it is going to return a list app event response tagger model tagger event. And then for that, what we can do here in our in is just do this, right? We can just invoke that function. We can do parse widget, if I can spell it correctly, sentence branch on our raw query text, and then we need our set op, so we're going to have to look into the model some more, right? So let me see here. That's in our file selection model. So file selection model dot set op. So let me see. It's giving us a type error, which what is it complaining about here? Parse widget sentence branch is applied to too few arguments. Oh, I see, I see. That's it. It saw those extra parameters and we're just so like it gave this type signature to just this value here instead of giving it to the entire function. So rather than defining that as a lambda, I wonder if I can do this. No. Okay. We'll just return a lambda. It's not that big of a deal, right? And then I'll probably wonder if I can put a where clause in there, and we'll just do that or something. So here's what I might do. I generally try to avoid putting actual functions in a let clause. I don't really think it matters that much, but I try to avoid doing that. So I wonder if I can put a where clause in here. Can I do that? I can. Okay, so I'm going to define my function in this where clause. Here, parse widget sentence branch. We'll give it its type signature just because I like to do that, even though you don't technically need to do that. Do that. And then we'll just call this function here. I feel like I'm doing things in kind of a weird way compared to how I usually do them, mostly because I'm trying to talk through what I'm doing as I'm doing it. as you can see, like most of these events are not structured this way at all. So I don't know if maybe I'm just thinking about it differently, or if it's just because I'm really conscious about how I'm doing things. But at the end of the day, if it works, it works, and you don't really have to think about it too much, right? T.strip model. Query text, like that. There we go. We've invoked our function. Now, just type-wise, you know, it does what we want it to do, which is really cool. That's my favorite part about Haskell, right? Is we have these types that pass, and it's great because like now the types work and the program works, right? even though it doesn't compile, because we have this hole here, the types are there, and that's really the most important part, which is really cool. So, okay, so now what we want to do, right, is we want to parse this. So we'll go ahead and just make our either here, and then we'll parse. We'll do our parser here. Request parser on our T, and then I put that in the wrong spot. T. This is just a, what did I call it before? I'll call it that. This string will show up in an error message. I don't know what the point of this is. It's like not very helpful most of the time to just have that show up. It's really kind of more confusing than it should be to just have that be there. But so here, all right. So in this either function, it's really kind of just a way to handle errors mostly. At least I think that's really the best way to use either. So this function will be called on a parse error if there is one, or it'll be called on the request, which is the successful condition if there is one. So we'll just say what we want to do with the error if there is one, right? So this has to be a lambda. We want to print our error to the user. So this is where we use some of Monomer's kind of like special syntax. And let me see how long this is going real quick. It's getting up there. It's almost 45 minutes long. I'm gonna finish this event and then probably call it for this one, and then maybe do another one later, or maybe take a little bit of a break. I don't know. Right. So this is where we get into how Monomer does events. Right. So when we want to print something, printing in Haskell is an I/O. It's an I/O event, right? And so that'll return a value that's in the I/O monad. So as you can see, like everything in here, they're pure values. We don't have anything in here. We don't have any IOs in the model. Yet our program does IO actions, right? So how does it do those? How does it do these IO actions where we read the database and then put a pure value back into our function? Well, the simple answer is that our program itself runs in the I/O environment. So that's kind of just how monads work, right? Is basically we run a I/O monad computation, and then we can just flat map it back. We can flat map the pure value back into our model. That conceptually is how that works. Implementation wise, it's not quite that simple. The fact of the matter is that the way that Monomer does I/O events to give you pure values back is something that I don't know the implementation details of myself. I hope that it's not calling unsafe I/O, right? I don't want it to do that, because that is just really kind of harebrained to me. Whether it is or not, I don't know. It shouldn't be. Right, there's no real reason why it should be, because like I said, Monomer runs in the I/O environment, so we should be able to just flat map our pure values back into the model and not have to worry about having I/O values, right? But we're going to tell Monomer that we want to do an I/O action, and we do that with task. So task will take a I/O event, so it'll take one of these events, and you can see these are all pure values too. It'll take one of these that's been lifted to the I/O monad, and then it'll run it in a separate thread. So if you remember in the part 5 tutorial, I mentioned that the database reads happen on a separate thread. That's not just the database reads. That's anything that requires an I/O action runs on a separate thread, and that's how Monomer works. That's not how I specifically designed the program, but it's how the UI library works, right? So here, like we have an example here, we have a task here where we add files. This is adding files to the database, right? So it does an I/O event, which is an event that I've defined, right? The I/O event takes nothing, and so frequently you'll see when you do an I/O action in Haskell, like it'll have a type signature of an I/O and then empty parentheses. That's pretty much literally what this event is supposed to do. It's just supposed to take that value, right? So that's all it does, is it just lifts one of my other events to the I/O monad, and then task will run that for me on a separate thread. So I need both I/O event and I need task to do I/O things, right? So I want to run an I/O event because I want to print the error message. So I'm going to run an I/O event, and then we're just going to lift that I/O event to this print, right? So I just want to do h put string line because it's an error, so I want to print it to standard error, right? That makes sense. This actually needs to be hprint. It's not super important why that is. Hprint calls show on this before it prints it, right? And show is just a type class that this error belongs to. It's not super important. And then here is our request, right? So we'll just call it a request. And this is our happy path, right? So what do we do with the request when the parse was successful? We want to add it to our model, right? So first of all, have a list. And then we want to run a model event. So this is another one of Monomer's type of special events, is a model. And all this does is just let you update your model. And this all runs in a main thread, right? This isn't doing some stupid like extra threaded trickery. This all runs in the main thread. So we want to update our model, and this uses a bunch of different lens operators. Don't worry about what these are. This is just like different function applications and stuff like that. File selection model. We want to push that to this guy, right? So to our file selection query widget request. That's spelled correctly. To that we want to set a value. Let's see. Okay, yeah, so that's alright. We can ignore that for now. And then we want to, we need to change that request. We need to, I'm getting another ping, hold on. We want to change that request to a widget sentence branch, so we need to invoke this function on that request, right? So we will just do this on rec. Rec. Oh, but first of all, we also need to append it, right? So we create it, but we also have a sequence that already exists, so we need to append it. So hold on. Do some function composition here. Append widget query node. Oh my gosh, hold on. Give me 1 second. This is really simple. I just gotta actually like figure out what I'm trying to do here. Okay. We'll use a different lens operator real quick. That's a widget query request, right? So our widget query request is there. Okay. That's perfect. So we can just, through the magic of currying, right? We can do some really cool things with that. Did I misspell that? Oh, right, we need our set operator, right? So we can just retrieve our set operator from our global global scope here. Oh, right, we don't even need that. That's given right there. That's our function argument. It's right there. Easy peasy, see? There we go. Bam. And there we go. See, we've updated our model. So now, whenever this event is called, it's going to read the text in this box, it's going to parse it, and then if it's successfully parsed, it's going to push it to our model's request sequence. So right now what we're missing is a UI element to show that sequence, and we're missing something that actually triggers that event happening, right? But this video is already long as hell, so I'm going to stop it and then maybe get back to another one, right? So thanks for watching if you've watched the whole thing. So yeah, talk to you later.